What the hell do we have here? This is a Cadillac that's on a square body Chevrolet frame and 5-ton Rockwells and big ass tractor tires with a 12 valve in it that is not feeling so good. This thing has the strangest noise I've ever heard in a while. I'm gonna floor it. I'm just gonna keep it to the floor. Got the hood open on this old girl, and I really don't like what I see so far. We've got this very restrictive air intake here. This is 2.5-inch tubing to a 4-inch inlet. This turbo's a 366, and it's also got a little baby 3-inch exhaust that is not mandrel bent. So we are not free flowing on the intake. We're not free flowing on the exhaust. That's problem number one. Gail Banks would not approve. Catch. Good job, Mike.
Ow, that's hot.
Well, I wish they were all that easy. Funny what happens when you relieve the inlet air problem. All this oil just came from a couple of free revs, now that this thing's running right, out of the crankcase vent here. That's not good. I blew an intercooler boost. Lame. Well, as you can see in our video, you heard that loud pop, so now we're going to check the intercooler system. And we got oh yeah, the whole boot blew in half. First thing on our list to repair is going to be the fuel system. He wants to upgrade to a Fass fuel system. This thing currently has a Beans diesel sump and a Blazer fuel tank with a little bitty 3/8-inch fuel hose that runs all the way up the chassis here to the engine. It goes into this power-driven diesel high-volume lift pump into the factory fuel filter housing, and then feeds the injection pump through the factory little baby tiny fuel line. So all the fuel for this engine flows through this little bitty fuel line here, and then this is the factory return port. This regulator here is what sets the fuel pressure. This fitting here restricts the flow going back to the tank, which causes pressure to build between this fitting and the lift pump down there. Factory fuel pressure is about 30 psi. As far as new parts go, we have a 250 gallon per hour titanium series Fass. It comes with a draw straw setup that we won't be using. We've got a Scheid adjustable regulated return. This is preset to 50 psi, which will be sufficient for this engine. P-pumps, the more pressure the better in most cases. I don't have a dyno, but going off all the information out there, most people just continue to see horsepower go up as they increase the fuel pressure. This is a dual feed kit for the injection pump, so you feed fuel from the side of the injection pump and from the front so that all of the plungers get equal fuel flow. If we were to just install this system the way it sits right now, we would create a pretty massive problem and hurt the injection pump, because this is a 50 psi regulator on this return circuit here, while this Fass is only set to 45 pounds because it's assuming you're using a factory return regulator. So right now, the Fass will not produce enough pressure to push any fuel through this return on the injection pump. We need to change that by adjusting the spring that is behind this fitting here. Fass sells adjustable springs from the factory. This is set at 45 psi. We bought a 65 psi spring, which is 15 pounds higher than our 50 psi regulator. So we'll be pushing fuel through the injection pump because this flows way more fuel than the injection pump can use. So we'll be flowing fuel through the injection pump to keep the injection pump cool, and then the Fass will also be returning fuel through this port here, keeping itself cool. If you don't have sufficient fuel return flow through the injection pump, you will overheat the pump and cause premature damage. Now I need to figure out where I want to mount that Fass lift pump. The customer did tell me he plans on 4-linking it in the future, so while with the current suspension setup we could easily mount the pump to the side of the frame here you wouldn't want to do that, because in the future, if he adds coilovers, they're likely going to go between the tire and the outside of the frame. He's only got about 8 inches worth of up travel currently, and so even if he were to do coilovers, he's not going to gain more up travel because the tires are going to hit the body. So I think we're going to mount it right in front of the fuel tank in between the frame rails. Don't forget, Fass wants you to lube the pump a little bit before you go installing the filters. Y'all know what I like to do with these. Pulled some of the 3/8 fuel line out of the frame we're not going to be using and cut it in half and draining the tank. Well, we've already run into our first problem. The fuel pump would mount perfectly if this was a show truck or something to the, man, this thing's heavy. Just, you're going to have to imagine it being mounted on the driver's side of the frame. That's very heavy. But we don't want to mount it on the outside of the frame because it'll be in harm's way of sticks and debris and whatever the hell he runs over in this monstrosity. Now we're underneath of this thing. This is the driver's side frame rail, and I want to mount it essentially straight in front of us where we're at. Well, you put the pump up there, you can see the problem is the bracket's on the wrong side. And Fass only has holes on one side of the pump. There's no mounting holes on this back side here. And for those that are going to say turn it around, well, you can't, because this end of the pump here is where the fuel comes out. So you want that to go to the front of the vehicle, not the back of the vehicle. So we're going to have to build a new bracket. Now we just got to come over here to the arc droid. Love this thing for the hobbyist welder man. We're going to pick our plate, and then we're going to tune it. And we have to set all these settings in here for 1/4 inch plate. We've got our old Fass bracket on top of our new one, and we're going to transfer punch the holes. This transfer punch has just a little bitty tit on the end of it, and it fits perfectly into our existing holes. Now we've got 3 nice little dimples so that we can drill these holes and know that our bracket's going to be square to the pump as far as like angle front to back. Oh no, step bit, what are you doing? That's a nice hole. Amazon deburring tools for the win. No hole ovulation required on this job. We got our plates all cleaned and prepped. There's no mill scale where we're going to be welding here. And I welded it on backwards. Y'all probably thought I was joking. I legitimately welded it upside down. Thankfully, I only tacked it. So now we got it right side up. All of our stuff is clamped down to the table. We're going to weld this thing. We've got our new bracket bolted to the side of the pump with the spacers. And then if you look at the comparison of the angle between this plate and our billet block there, that son of a gun is square, boy. I opted to reuse these aluminum spacers. You could mount this piece of steel plate up against this anodized aluminum housing, but if this plate is not perfectly flush with this aluminum piece, then the filter could hit this steel plate before it bottoms out against the O-ring. We just don't want that problem to happen. Fass supplies these aluminum spacers with their bracket, so I just opted to say, you know what, their engineering department included them, so my engineering department is going to reuse them. Fass sent these O-ring Boss to AN adapters Can anybody see what's wrong with them? Somebody installed the O-ring on the wrong side. This is the side that does not use the O-ring, and this one is. Well, I really didn't want to have to mess with these, but the bump stops from the factory frame have got to go. They are going to hit the fuel filters. Now we've got to air hammer the rivets out of the frame. And don't laugh, it's cold outside. Well, we got her welded in. Pretty solid. Not going anywhere. And got it level this way, level from the back and the front and all that stuff. So now we're going to pull it off and paint the bracket and then start running fuel hose. Michael's got the wonderful task of gutting the factory fuel system. So this is the factory mechanical lift pump. This runs on the camshaft and it pushes it in and out to pump fuel from the tank to the injection pump. Well, I thought we had drained all the fuel already, but we ran into another surprise when I cut this fuel line off. And it started dumping fuel back out of this fuel tank. And I was like, dang, like it stopped draining fuel. What the hell's going on? And you can kind of see what's going on here. You see how the fuel tank's got a big old air gap between this fuel tank strap and there? That's because I ran this hose down into a bucket and started filling it up with fuel, and then it kind of just stops draining fuel. Do you hear that? The fuel tank vent is clogged, and so we can actually suck the fuel back up into the tank now. That's not good, because that will starve the Fass that we're installing of fuel and cause it to make all kinds of terrible noises. And once the vacuum releases, we get more fuel out of the tank. Here we're going on top of the fuel tank, and you can see that we have the factory. This is the vent hose for whenever you're filling the tank so it doesn't like gurgle back at you. This is probably the return line coming from the factory fuel pump, but that will suffice for a fuel tank vent. It doesn't matter if it goes down into the fuel, it'll just suck air through the hose. So we're gonna plug off this with like a bolt or sleeve or something, and then we'll attach a new hose onto here and run it up in the fender over here so it doesn't get dirty. We got our official mud truck hose plug here, and then we got some new 5/16 fuel hose. Run along the filler hose here to the back of the car, and we come up here, and the vent is a Dorman differential vent right there. It's kind of the highest point without running like 20 foot of hose. If he manages to get water inside that fuel tank vent, he's got bigger problems because the Rockwells still have the factory differential vent there. So he's going to be like, have water 4 feet over top of that. Well, this was a bust. There's no air coming out of here. And I tried pushing air in here with the fuel cap off, and just the smallest amount of air goes inside this hose. So there is a massive restriction inside the tank. Okay, I'm done asking. We're going to drill a hole in this thing, put a little weld bung in there, put our own vent on the side of the filler neck. Be easy for the customer access in the future if it ever clogs up, and I don't have to deal with their very rusty antique Blazer fuel tank that's in the vehicle now. If I try and disturb that, I know I'm just going to open up a whole nother can of worms. Got our bung welded in there. It was galvanized, so it didn't weld all that pretty. And got our 90-degree 1/8 inch MPT adapter and a little differential vent hose, so that'll be a really nice high point away from all the water and mud, and our fuel tank won't be collapsing now due to vacuum. We gave that plugged up hose the bolt routine just in case it ever decides to leak. And this filler hose was just zip tied up in here. Let's see if we can't do something a little better than that. So what we're going to do, we're going to take this gauge retention device, we're going to weld it across this gap here, and then that'll give us something to hose clamp this filler hose to. The old fuel filler hose mount, trash. That new one though, is rock solid. Okay, so Michael already took all this apart, but I just laid it back in here so you can get the idea. The fuel from the fuel pump on the side of the engine comes into the filter here, goes through the filter, comes out this port, and goes into the side of the injection pump on the driver's side. Return fuel comes out of the injection pump here and runs back to the tank. The injector return coming off of the fuel injectors is this little bitty line here, and it actually goes back into the feed line from the factory. We will not be doing this. It's going to go into the return line going back to the tank. I'm kind of confused as to why the factory ever did it that way, but I'm not an engineer either. But on these trucks, you have to cut this factory return line and put a crimp fitting on there, and then I'll show you how Fass wants you to do it. This is our line for the injector return. We have to cut that off and put this crimp ferrule on there, and then that way the line has some threads on it that you can use. So we'll cut it back here and we'll crimp this down. Fass sends you this contraption here, which is just a T-block, so that your fuel return coming out of the injection pump can go in here, and then this goes back to the tank, and this is where your injector return line goes in. And they've got a 1/4 inch MPT to 1/8 inch adapter, and so this whole thing ends up looking like this when it's all said and done. Big ugly thing hanging off the side of the engine, weighs a ton. I don't like that idea. I prefer to essentially do the same thing but with a much smaller fitting. So bam, we got the exact same thing. Our 1/8 inch MPT screws into here, and we get 3/8 in and out with a much lighter, more professional looking setup with a lot less junctions to leak. This only has this one threaded section here that could ever potentially leak, versus this one has 1, 2, 3, 4 places to leak. So Fass should really look into just supplying these with the kit, in my opinion. What the hell is going on around here? This fitting has an O-ring here when it is not a style fitting that uses an O-ring. This is just a normal AN fitting that seats up against this flange here. This O-ring does nothing. And this regulator doesn't have any directions, doesn't say in or out, but if you look down the barrel of it here, you can see the spring, and so this is going to be our outlet, because there's a ball right here at the tip of my finger, and that spring is down here, and the fuel pressure has to push that ball and spring down in order for fuel to flow. So this is the inlet to the regulator. We got some 3/8 inch rubber fuel hose that we have to use to couple this to the return fitting that we spoke about on the engine, and then from here down to the frame to go back to the fuel tank. This is diesel compatible, but it is not push lock fitting hose. Parker sells specific hose for push lock fittings. We don't have that. It's not high pressure. This shouldn't have but a couple of pounds of pressure in it at any time. So while we could probably just push this onto the fitting and be just fine, we're going to use these heat shrink hose clamps over top of this hose on these barbed connections here, just to prevent it from ever wanting to come off. This fitting here actually comes with these cheap little clamps. I don't use worm drive clamps if I can help it, because it digs into the hose and it's not a constant tension hose clamp, versus these are a constant tension hose clamp. The return line on the injection pump's installed, routed real nice, got the heat shrink hose clamps on all the connections here. This line is the one that goes back to the tank, and then I used an Adel clamp to mount this entire assembly to the intake manifold, so that the line isn't, like all this stuff here, isn't pulling on this little dainty return line that's metal, because these can crack, especially if you go hanging weight on them. So this is mounted really solid. It'll never have a problem. Now we're going to work on the dual feed for the injection pump. I've got to go around the front here and take out this fitting, so I blew it off really well. We'll brake clean it off and take that plug out so we don't get any debris inside the injection pump, since this is going to be post filtration. If you get any debris in here, it's going to go straight into the plungers, and that's not good. She's trying to play hard to get. Don't make my day into a bad one, girl. Oh yeah, she's coming. Got all the dual feed installed there. It feeds inside the pump where the factory line went there. We're done up in the top of this engine bay for now. We got the dual feed kit here, and this is pretty much how the hose is going to route. I don't like how it's obviously touching our steering shaft. We could go on the outside of the steering shaft, maybe, but there's nothing to attach the hose to, and I sure don't want to get into these steering bolts here. So I think what we're going to do, run the hose on the inside somewhere about here, and we're going to make this blue hose as short as possible so that this fitting gets closer to the injection pump to keep our hose away from things we don't want it hitting here. I'm working on running the fuel line back to the Fass from the engine, and I got an Adel clamp here to hold it away from the steering shaft. I wanted to put one here, but somebody plated the inside of the frame from about here back, And so there's no way to access the backside of this, and it's double wall, so went ahead and tapped her for some threads. Okay, so this is the final product on the Fass install as far as the engine bay is concerned. We've got the fuse mounted here, nice connections on the battery terminal. Relay is mounted to the fender. We've got the trigger wire running down the fender with these, I call them Christmas tree zip ties. You drill a hole and you stick the zip tie in there and then it won't pull out. And then that wire runs up in the interior to go to the switch panel. The wires that feed the pump go down to the fuel line. That's the cleanest way I could route them. Now we're in the inner fender here, and those wires come down here and run along the back side of the fuel line. Can't see it, nice and clean. We've got 2 Adele clamps holding the fuel line to the chassis so that it doesn't move. We have good clearance between the steering shaft and our hose here, at least an inch or so. And I actually put this Adele clamp in the vise and bent it like this so that it wouldn't be trying to pull the fuel line down in the front. And I have a 45 on here, and this is kind of angled like this. But these fuel hoses, even when they're pushed on all the way, you can still rotate them. Here, like all of this stuff pivots with ease. So that's why I went ahead and put these Adele clamps here instead of just zip tying it to something, because these, they're just small enough where it like grabs the hose and the hose doesn't move in or out with ease. Like you'd really have to pull on that to move it. So that is what's mounting our hose to keep all this nice and straight the way I want it. When the motor torques in the chassis, there's still plenty of flex in this thing for it to move around without ever coming back to a neutral position where it's touching the steering shaft. We've got the fleece fuel pump block off plate here. Still got to add my secondary crankcase vent hose here yet. A couple of things to note about cheap fittings. They'll get you out of a bind, like in this case. I didn't want to have to wait several days for an order from Summit Racing or something like that. The O-rings that these things come with are absolutely trash, so we changed these O-rings out for some quality ones. The fitting on the left is the one that Fass sends, and the fitting on the right is the cheap Amazon one. You can see the diameter difference, so we're going to drill this one out. Shoo-wee! We got full flow now, son. We got a couple of springs here from Fass. One of them's for my personal truck. And we just got to pull this fitting here. And behind door number 1, we have our factory spring, which is only good for 40 PSI. And these other ones are good for 65. The old personal rig looking pretty sore here. But whenever we were building this thing, we were in a time crunch. I didn't have time to order that spring from Fass for the regulator. So I just took this spring and stretched it, and that bumped the pressure up. So if you're ever in a pinch, you can try that. Here's our finished install. We have both hoses coming from the sump. This is our suction line. I opted to put a 45 on it so that it kind of angles it up. From the factory, Fass supplies a straight fitting here, and so it would have tried to kink the hose coming down due to the weight of the hose. And then this is our return line coming from the Fass. I've got some heater hose over here to try and keep abrasions down because the side of this frame is sharp, and so is this bracket here. There was just not a real great way to run that with the sump. On the return fitting here, we have a 120-degree elbow so that it's not stressing the hose. If we had used a 90-degree fitting here, it would have pointed straight up at the frame here, and then it tried to pinch the hose off. We didn't want that, so I got this nice fitting so that the hose runs nice and smoothly to the rear of the truck. This is our outlet and our wiring running up the side of the chassis. Tried to route it away from any abrasive surfaces. Here we are in the driver fender well. Got the Adele clamps holding the hose real nice. And it goes into our union up here for the dual feed. All nice and pretty like. Ready to rip. This is how she's looking from the back. Nice clean routing. There is 0% chance this rotor will ever travel high enough to hit these hoses. If they did, it'd crash into the fuel tank anyways, but you got like 10 or 11 inches here, and the tire's only got about 6 inches before it touches the fender over there. Not to mention this suspension can't travel because these shackles are hitting the shackle flip kit. Now we get to make a mess. We're gonna loosen this front filter. Michael, turn it on. Turn it off. Okay, turn it back on. That's it. It'll kind of sound funny while it's purging all the air out of the system. Clear prop. Come on, bitch. I was worried on that one. Currently this thing has an air-to-air intercooler, and the second it started making power, it blew this boot up here. And we don't have another boot for that, and I want to test drive this thing, and the customer's going to take care of doing the intercooler delete or whatever he's going to end up doing on this thing. So I took the boots here and I'm rotating them down, and I'm just going to run a delete pipe across here so we can run this thing and make sure all is well before it leaves. But look at all that dirt on the inside of this thing. Air filters are important, people. We got our custom intercooler delete pipe here, and if we want to have any chance of success, we need to bead roll this end to keep it from pulling out of the intercooler boot. And this little cheapo bead roller is only meant for aluminum, but I've done stainless with it. It just takes a very long time. I have my third hand holding this end so that I don't have to have Michael stand there and hold it. Now we have a mediocrely done bead roll. You can also just put some weld on here if you didn't have a bead roller, and it does the same thing. Like a glove. If you see this at the local mud park, this was free, just for testing. It's always something. The Horde provides. We got our secondary crankcase vent hose added. Nothing fancy, they're just dumped down by the side of the oil pan. Y'all figure we should tighten those? I'm going to demonstrate now what that air intake boot was doing under boost, where it would gray smoke and pop and stuff. And that boot would stay collapsed like that until you let off the throttle. That's why it would never regain power until you let off the throttle, and the boot would open back up. And then you have power again until you start making boost, and it'd suck it closed.
Might be a little warm.
Dude, it freaking launched that intercooler pipe. Don't tell the wife, but I'm jacking her hairspray for intercooler pipe adhesion. You spray it on the pipes and it kind of glues the, it acts as an adhesive for the intercooler pipes themselves to the boots. I do not have high hopes that this is going to work because these are really thin wall aluminum pipes and they bent extremely easy, so that intercooler clamp can't really squeeze down on this very good. So we're going to go see which one launches out of the hood next. He's also running the wastegate delete mod here, so I have no idea how much boost this thing's making. There's no way to regulate it. Some people on these S366s can see like 70 pounds of boost, so it wouldn't surprise me. This thing was really making some steam when that thing let go. This is the driver's side intercooler pipe that hasn't left the chat yet, and you can see it is oval shaped from that intercooler clamp, so hang in there, buddy. I refuse to let y'all hang like that, so we're gonna go ahead and build us some intercooler poop. Intercooler pipes. I'm not getting paid for this at all, but I cannot let this thing leave without finishing the video, and that 1-2 rip wasn't enough for me. Well, that's an hour of my life I'm not gonna get back, but we have all second gen 3-inch steel intercooler pipe in here. We've got good second gen intercooler clamps, not some cheap Chinese ones, so you can just hammer down on those all day. Got some 3-inch exhaust tubing, a 3-inch 90, booger welded, baby. And then another second gen 3-inch intercooler pipe here. If it comes apart now, I don't know what to do. Well, we got 1 mile worth of test driving done on this thing. We don't have any leaks. Hit the switch, Mike. The pump sounds really nice and quiet. That's as quiet as a 250 gallon per hour Fass is gonna be. Our bracket is solid. We're good to go. And now that we have dual crankcase vents, we do not have excessive pressure, and there's no oil blowing all over the axle like there was before. We've done several, at least 4,000 RPM pulls in this thing, and not a drop of oil on the axle versus before, just neutral revving it. We blew oil all over the ground. So crankcase ventilation is extremely important on these engines.